Hello friends, good evening again. So today, uh, where is our topic? Okay, yeah. So today we are going to discuss WebSockets. Okay, so very simple concept, but important, right? So if you are new, so this is a high-level design series. So we discussed already all the designs, high-level design for all these, things, and you have two options. Either you can go my playlist, you can watch out all the topics, otherwise you can go with these notes as well, right? System design, HLD, you will get all the like notes here, building blocks here, and then for low level design, like I will create one LLD, not now, might be after two videos. We'll discuss a little bit about checksum and distributed locking, and then we're gonna have trade-off, not LLD, my bad. We're gonna have trade-offs. So at least 1 or 2 months we'll spend on these trade-offs as well. And then we have some patterns, only one video, and then we're gonna have LLD, and we're gonna write codes, right, for these LLD concepts, right? And without wasting time, let's discuss WebSocket. And one more thing, I always uh, create notes as well, right? So here, mm, here we go. This is a WebSocket notes as well. So I will paste these notes in the description, video description as well. Okay, so let's discuss WebSocket. So first of all, why we use, or what kind of question like comes, right? So WebSocket in high level design, how does WhatsApp instantly deliver the message? Like question asked by the interviewer, he or she can ask, right? Interviewer can ask, how a stock trading app update price in real time, right? So WebSockets work in real time. Okay, how do multiplayer game synchronize players? Okay, so these are the kind of question, or to sum up, any real time data persistency, right? Persistent question arrives. It means interviewer is indirectly asking for WebSockets. Okay, so now without WebSockets, so first of all, just understand the communication, right? So we have HTTP connection, we have WebSockets, right? In HTTP, we're gonna have client server. Client will send request to server, response, done. Then connection will close. Again, client will send connection, response, right, done. Okay, but in WebSockets, what happened? It handshakes, handshakes, right? Then connection, then it will send response. Okay, then it will not gonna close. It will still open, right? Whatever after that they can communicate, right? They can communicate for long. So we call this as persistent as well, like persistent connections. Okay, we will discuss, right? We'll discuss later on. We have what protocols it follows, what protocols it follows, right? But at high level, this is a story for HTTP and WebSockets, right? So without WebSocket, browser will ask server, any update? No. ठीक है, one go. 5 seconds later, browser, any update? Server, no. Second go, right? So every time connection establishment is there. Okay, connection establishment is there. Again, After 5 seconds, any update? India's code, right? So browser keep asking repeatedly. Now, if you see this example, one nothing, two nothing. So this is also wastage, right? Wastage of resources because CPU, memory, whatever, right? Because of like empty calls, right? So this is called pooling, right? Meaning fetching the data, right? Asking server to give me the data is called kind of polling. Okay. So polling have two types. I already discussed in some videos: short polling and long polling. So short polling is instant polling like this. Any update? Server, no, done. Long polling like we can have some wait time. It will ask, client will ask to server score, right? And it will give some time, suppose 5 seconds. Okay, 5 seconds, right? Client will wait for 5 seconds. It will respond or not, right? So it is a kind of long polling. Okay, no problem. Too many unnecessary requests, whatever I discussed. Wastage here, right? CPU wastage, bandwidth, latency, 5 million users are polling every 5 seconds, 5 million requests every 5 seconds, server are busy answering, right? No update, no update. So wastage, right? So solution is WebSocket. So first of all, we have to see use case, right? So requirement. If we are, so right now you have seen HTTP, right? So our websites, kind of Amazon.com as well, right? So they use HTTPS. Doesn't matter, right? Because they don't need real-time data. Like, sorry, not data. They don't need real-time communication, right? And if I talk about web teams, right? Teams or our WhatsApps, right? So they use WebSockets, right? Why? Because they need real time. Like client one send data to client two, something like that, right? Server is sitting here. So everything is real time. Everything is real time, right? So it needs WebSockets. Again, we have one more thing: event ESS, event socket. Okay, event socket send something, right? So again, it's a unidirection, right? It's a unidirection. So it depends, right? What is our use case? Okay, so let's come back. Uh, so this is not a ESS, SSE, server sent events, server sent events, unidirection. Okay, let's come back to this HTTP versus WebSockets. So HTTP is like a simple get message, right? Server response, connection closed, whatever we discussed before, right? And in case of WebSocket, client handshake, right? Okay. So when it handshake, I think we missed that or not, or or it will come later. Okay, might be it will come later. So it get response 101, right? When we handshake, right? Client handshake with server, okay, with 101 protocol, right? It means connection opened. Now do real-time communications. So just like as real-time analogy, right? Simple. Now you know, right? Just like as our mobile call. Mobile call is our WebSocket. Okay. Um, person one, person two. Call establishment, and they can communicate whatever they need, right? Real time. Okay. So again, architecture, how it works: internet, load balancer, WebSocket server one, WebSocket server two. It's gonna have thousands of users. It's gonna have thousands of users. We're gonna handle like this. Okay. So now you will see what is WebSocket server, right? So at high level, we will open a WebSocket, right? We, right, as a dev, we will write a code, right, to open a WebSocket, right? So internally, when we gonna use our libraries, right? So they will manage a kind of WebSocket server behind the scene. Okay, so that's why we are saying WebSocket server one, WebSocket server two. Okay, for managing our thousands of users. So every server maintain thousands of open TCP connections. So this is a TCP connection. Whatever we make communication connection, we call it as a TCP connection. Okay. So here we go. Here I wrote. I thought I wrote somewhere. So WebSocket handshake. Initially, everything start with HTTP. So you need to keep in mind. This is an interview question as well. Server, not server. Actually, this is a client. Okay. When client send a request to server for handshake, right? So that initial request will be HTTP. Just keep in mind the initial request will be HTTP. Okay. Then client HTTP request upgrade WebSocket, then server. Okay. The initial request will be HTTP, and after that it will becomes WebSocket. Okay. Now 101 switching protocol. After this HTTP become WebSocket. Okay. What does it means? It goes first time it goes HTTP request. It will return 101 switching protocol. Okay, it means connection established, and this will update to WebSocket. So when you will communicate with server, just like as whatever for chat application, hi, you wrote something, it will be go through our this channel. Okay, communication flow. Client says hello to the server. Server returns hi. Okay, client send message to the server. Delivered. Both side can initiate communication. Okay, so this is also called bi-directional communication as well. Okay, so point to be noted: HTTP WebSocket. So it supports unidirectional communication. Okay, it supports bi-directional communication. Okay, request closed after response. Request, or I can say not request, actually connection Connection closed after response. So connection persisted after handshake. Okay, so we called it as persistent connection as well. So we can say this is our, so this is same. This is a kind of example, kind of small definition, right? So we can say persistent connection as well. Okay, persistent connection as well. Open ones keep alive. So this is a kind of HTTP open close open close open close, but this is open ones keep alive. Okay, the same. What's the example? Alice, hello, WebSocket, Bob, right? The Alice send message hello. It will go to WebSocket. It will send to Bob immediately. The server doesn't wait for Bob to ask. It pushes the message. So again, so WebSocket is a push-based protocol. Okay, it is a push-based protocol. It will send the data, right? Just like as Kafka, sorry, consumer, not Kafka. Consumer pulls, right? Consumer pulls or pulls, right? But this WebSocket sends. Okay, large scale architecture. We already taken high level idea. Internet, load balancer, server 1, 2, 3. Then how communication will get passed? We can attach, our some other strategies as well. Just like as we can pass to Redis, we can pass to PubSub, we can pass to Kafka message broker. Okay, then it will go to database or whatever we need to do operation, right? So simple. The same example, Alice send message hello, it will go to WebSocket, then again it will pass to Kafka, Redis or whatever, then it will go to web server 3, WebSocket 3, not web server, WebSocket 3, and then it will pass to the Bob. Finally, it will reach to here. Okay, so this is a strategy. Okay, this is a kind of strategy. Without Kafka, server 1 won't know where the Bob is. Okay, Alice send hi to server, store in database, publish event, Bob socket, server socket, push message, Bob sees the message, no polling. Simple, okay. Here is Alice, here is Bob. So here we have Redis or Kafka. Okay, but you know, right? He send the message, Alice send a message, hi, Kafka. So Kafka is a push-based approach only. Meaning Kafka, sorry, message will come here, right? And WebSocket will push, not Kafka, my bad. WebSocket will push the message to Bob. Hi. Simple. Now, why we are using Kafka? Why we are using Kafka? Let's see. So imagine server 1 knows Alice, server 2 knows Charlie, server 3 knows Bob. Okay. If Alice send message to server 1, where is Bob? Okay. Redis, PubSub Kafka broadcast the message. Sorry, broadcast even like this. Server 1, Redis, server 3, Bob. Okay. So what I'm trying to tell, server 1, server 2, server 3. Here we have Alice, Here we have Charlie, where we have Bob. Okay, now Alice has to send message, right? Now, how do we know where is Bob or how to send a message? So we have some interface like message queue or whatever, right? Through WS, we publish like message to here, hi, right? And somehow these are connected to here, right? So server 1, Redis, server 3. Server 1, Redis, Redis or message whatever, server 3. Okay. Message will come here, then message will publish to push to Bob. Okay. So kind of interface. Okay. Remember, we were using like this client, server, message connected, right? But chat application, client, right? In that way, we can use intermediate like this layer. Okay. Now, heartbeat mechanism, it will come in everything, right? Everywhere it will come. Connection may silently break. Client, ping, server, pong. If no connection, it means dead, right? Every time. Heartbeat mechanism is like kind of global thing, right? Client, server. So you know, right? Handshake, connection build, right? Now, if connection fails, how come we know there's a connection, right? So again, heartbeat mechanism every 5 second or 10 second, it will listen something, right? They will send something, it will listen something. If no response, connection dead. Every WebSocket server perform health check. Now, scaling challenge. Okay, we are writing like this client server. But what about scaling? We are not used any application or what, right? Because first of all, this is a stateful. Keep in mind, this is a stateful. If this stateful, scalability is difficult. Okay, scalability is difficult. One server can handle 100,000 users. What about 20 million users? You cannot use one server, right? So that's why instead of we are using load balancer, whatever we I showed you in the previous diagram, right? Client, load balancer, then WebSocket 1, WebSocket 2, WebSocket 3. Okay, in that way, it will handle 100K, it will handle 100K, it will handle 100K. And if you have to process 20 million, so might be thousands of servers we're gonna use, right? Simple. So sticky sessions. So you know sticky sessions, right? Meaning if client is going to connect with server one, it will always connect with server. If suppose it connection is lost, but still client one will connect with server one only. So this is the sticky session. A WebSocket connection must remain on the same server after it established. Client, load balancer, server 5. So it will connect it with server 5 only. This is the sticky session. Okay. Okay, you can leave this. Now, advantages and disadvantages. Real-time communication, low latency, bidirectional messaging, less network overhead, reduced bandwidth and computer polling, better experience. Disadvantages. O1. This is the open actually. This is not O1. This is my mistake. This is open. Okay. Open connection. Open connections consume server memory. Harder to scale than stateless. Whatever I explained, right? Stateful is harder to scale. Stateless is easy. Okay. Load balancer requires connection and aware routing. Ideal connection needs heartbeat as well. Not ideal for simple response APIs. So simple, right? We already discussed wastage. So use case WhatsApp, instant messaging. We're gonna use WebSocket, Slack, live collaboration, Slack or Teams, whatever. Both are same category. Live collaboration, chat, gaming, trading, ride sharing, whatever, food application. Everyone they are using WebSockets only. So these are some details only I wrote here. You can read this out later as well. Just like as for small actions, like small actions or only actions, login, updation, this and that, we're gonna use RESTful APIs. For persistency or like long-term push updates, messages, notifications, news channels, right? Use these sockets, web sockets. Okay. So again, how would you design a real-time chat system? So suppose if Enter asks you one question, how would you design a chat system? So a strong high-level answer is, so you have to step by step. I wrote only steps. You have to do what you have to do. Client authorize using HTTP. You have to draw diagrams as well. Client, server, client will get authorization with REST APIs. Okay, now client is sorry, not authorize, authenticates. Now client is authenticated. Okay, client upgrades the connection to a WebSocket. You can write here Handshake, and it upgrades to WebSocket. You can remove for the time being. Load balancer routes the connection to the WebSocket server. Whatever we discussed in previous slide, we have to draw that diagram then. When a user sends a message, the server validates it and store it to database. Again, we already draw the diagram, the same diagram. The message is published to message broker such as Kafka. Again, you have to draw one message, draw one diagram. The WebSocket server hosting the recipient receives the event, immediately pushes the message to recipient over the existing WebSocket connection. Again, you have to draw one diagram. Okay, heartbeat, you have to explain. You can, not mandatory, you can draw a diagram or just explain like this. Heartbeat thing, right? So this is a high level design. You have to write step by step, right? So first of all, you have to explain what is WebSocket. Then step by step, you have to explain one, two, three, four. So in this way, we design high level. So we explain the things in high level design interviews, right? So this is our WebSocket. Simple, right? If still you have any questions, doubts, let me know or comment. You can do comment as well, right? And for now, I'm closing the video here. If you're new, then subscribe the channel because I'm coming with new videos, concepts, right? I'm always there to help you as well. And bye for now. Thanks.